A function in the world of math is basically anything that changes one thing into another thing. Kind of a formula generally in math that changes one thing into another thing. But visually it's kind of like this. Now you're going to see a picture like this in most of the algebra books that you've seen. You kind of see these big oval looking shapes. These are here to represent sets. Now all this set is a group of things. Now normally we denote a set using curly brackets, kind of like this. So this would be a set of numbers, and this set contains, in this case, 3 elements. The things in a set are generally called elements. So let's say, this is just kind of a different representation. So let's say here we have a set, and in this case, let's say it does have the numbers 1, 2, and 3. And for this set, I don't know, 2, 4, and 6. Now, we're going to try to imagine some invisible machine here in the middle. And what we're going to do is we're going to take these numbers over here, plug them into a machine, and see what happens. Now, I'm going to draw these arrows to show what, for the first case, what I'm going to say is going to happen when we plug it into that machine. So in this case, if I take a 1 and plug it into this invisible machine, it changes into a 2. If I plug a 2 into the invisible machine, it turns it into a 4, and a 3 into a 6. Now notice, we're using this set of numbers over here as our input. We generally call this the domain. This was the output of the function, and we generally call this the range. So the input's the domain, and the output is the range. Now, generically speaking, I would like to refer to all these by one name instead of individuals. Kind of like if you were in a classroom, I could call you by your name, that's referring to you as an individual, but sometimes I just want to refer to you guys as my math class, and that way I'm referring to all you students by one particular name. So I'm going to call all these guys, we generally call these X's, and the ranges we generally call Y's. Now the nice thing by stating what it is like this, sometimes we can actually write down exactly what this invisible machine is doing. And I know you've all noticed, what does this machine do to everything that we plug it into? It doubles it. Or you could say all the Y's are twice the X's. See, now we can write down an equation that tells us exactly what this function or relationship is. Now you're going to hear that word a lot in this section in your homework, also a relation. Anything that changes one set of numbers into another set of numbers, or one group of things into another group of things, is called a relation or a relationship. However, we're going to talk about specific types of relationships called functions. All right, so let's actually get some more definitions here. Domain. Now, we're thinking about these things in terms of machines. And a machine that we all deal with, especially when we're here on campus, is like a vending machine. And you can kind of think about a vending machine in terms of functions also, or relationships. A vending machine has an input and it has an output. So if I were to ask you what the input or the domain of a vending machine is, you might say, well, it takes money. And you'd almost be right. Kind of like if I said, what's the domain, and you said it's the X's, you'd almost be right. See, a vending machine can't take any type of money, right? Generally, a vending machine can't take $100 bills. So it's really talking about the value of the money that you could plug into it. So let's take a look at a quick little example. If I looked at the machine, y equals 1 over x minus 3, you can see I would never be allowed to plug a 3 into this because that would make a 0 in the denominator, and we know we're never allowed to divide by 0. So the domain is actually the values you are allowed to plug in. So think about our vending machine. Most vending machines generally take what? Ones and fives a lot of times now, and what, quarters, nickels, and dimes. So that would be the domain. Now they're all money, but it's not all money that you're allowed to plug in. Now for the range is the output, what's allowed to come out. So same type of idea, if you go to your vending machine and you put in your dollar, you can't get out a turkey dinner. right? You can only get out what's available right there. So it's the values that can come out. Okay, so the domains, the values you're allowed to plug in, generically speaking, those are going to be X values. And the range of the values that are going to come out of the machine, and generically speaking, those are Y values. Now, we've been talking about functions, and I've been throwing the word around relations. Well, basically anything in math is going to be a relation or a relationship. So what exactly is the definition of a function? Let's go ahead and get kind of the math definition up here first. It's a little tricky. It's a relation in which for every element of the domain there exists only one element in the range. Okay, a relationship in which every element of the domain there exists only one element of the range. Now, I know you're sitting there going, well, gee, that really helped, thanks. Now I really understand on a function. Well, let's see if we can maybe ease up some of the language here. Now, since everything in math is basically a relation, I'm going to leave that part off. And we know the elements of the domain, well, generically speaking, we're going to call those x's. So I'm just going to say for every x, there exists only one element in the range. Well, we generically call those y. So for every x, there is only one y. So kind of a scary sounding sentence, but that's really all that it means. It means that for every x that you plug in, you only get one y value out. So if we look at this relationship over here, I plugged in a 1, I only got out a 2. I plugged in a 2, I only got out of a 4. I plugged in a 3, I only got out of 6. So this picture would represent a function. And I can change it up. So let's see, from the first picture, if I were to do this, what do you think? Is that still a function? Well, some of you out there are going, no, it's not. But it actually is. Because notice, if I plug a 1 into the machine, it only gives me a 2. If I plug a 2 in the machine, it only gives me a 2. If I plug a 3 in the machine, it only gives me a 6. It didn't say that when you plug in a value, you can't get the same value out. It just says when you plug something in, you can only get one thing out. However, if I change my picture a little bit and draw it like this, now this is no longer a function because here you plug in a 2 and you got out a 2 and the 4. Now here's where our vending machine kind of breaks down the analogy that I was trying to do. But you can kind of think about it like this. When you go up to a vending machine and you see that bag of chips hanging there and you want the Snickers bar too, so you buy a Snickers bar right above the bag of chips hoping you get 2 things out. Well, most of the time, it's kind of a function. You plug in one thing, it gives you one thing out. But you're trying to cheat the system, put in your dollar and get out a Snickers bar and a bag of chips. That would mean it's no longer a function. For a lot of your homework tonight, for your homework, you're going to determine if something is a function or not. How to determine if something is a function. Now, the author here, whichever textbook that you happen to be using, or that you happen to look at, generally are going to present this information in 3 different ways. The first way is a set of points. The second way they may give it to you is, let's say, a graph. And the third way is an equation. All right, so actually I'm going to leave this picture up just for a second. So let's take a look at the set of points. For a set of points might look something like this. Well, the set notation, they're probably going to use the curly brackets here. Maybe like 1, 2, 5, 8, negative 3, 6, 2, negative 5. All right, they would give you a set of points like this and say, does this represent a function? Well, basically what you're looking for is you're looking for a repeated input without having a repeated output. What does that mean? It means if you plug in an x value, you should only get one y value out. So let's start with here. I plugged in a 1 and I got a 2. Did I ever plug in a 1 again? No, I didn't, so the 1's fine. I plugged in a 5, I got out an 8. Never plugged in a 5 again, so that's fine. Plugged in a -3, I got out a 6. -3 was never plugged in again, so that's fine. Same thing for the 2. So if you think about this in terms of domain and range, what we plugged in and what we got out, the domain for this was 1, 5, -3, 2, and the range was 2, 8, 6, -5, right? The x values are the domain, the y values are the range. Now, since in this case, for every x that I plugged in, I only got one y value out, this would actually be a function. Now notice we didn't do any work here, so to speak. We did this by inspection, just by looking at it and determining whether or not it was. So let's take a look at another example. Let's say we have 3, 5, 8, -2, 3, 7, 6, 1. Okay, so again, here I have a set of 4 points. Does this represent a function? When we started looking at it, here we plugged in a 3 and we got out a 5, but over here we plugged in a 3 and got out a 7, which means when we plugged in a 3, we got out 2 separate y values. That means that this is not a function, right? For this x value, we got 2 different y values. Now be careful, let's take a look at one more here, because really this is just done by inspection. 4, 2, and I don't know, 8, 6. All right, a really common mistake that you would make, if I were to ask you whether or not this is a function, some of you would already be saying, no, it's not a function, because the 8's plugged in twice. But notice here, what did we get out? We plugged in an 8, we got out a 6, plugged in an 8, we got out a 6. The machine still only gave us one y value when we plugged in that x value. It's just doing the same thing over and over again. So as long as the x and y value are the same, this is still a function. So be careful, just because you see a repeated x value does not mean it's not a function. It has to have a different y value with it also. All right, now another way that they can present this set of points, and this is why I left this up here, is a picture like this, because this is actually a set of points. Right? If you were to take a look at this is an x value paired with a y value, so that line going across there, you can think about it as the point 1, 2. Next line you can think about as the point 2, 2, 2, 4, and the last one could be considered the point 3, 6. So when you see a graph like this is really just a set of points. Think about the x value, did you get out more than one y value? Exactly the same way we did with this. So a set of points is one way that the author is going to ask you whether or not something is a function. Another way is by looking at the graph. So just going to give you a picture of something and say, hey, does this represent a function? So let's take a look at a picture here. So from this picture, can we tell, does this, because remember all this is an infinite set of points. Does this set of points represent a function? Well, to do this, we're going to use something called the vertical line test. And here's what the vertical line test says. If you can draw a vertical line and hit the graph more than once, it is not a function. All right, so vertical line test. If you can draw a vertical line and hit the graph more than once anywhere, then it is not a function. Now, you don't actually have to draw vertical lines here. Again, we do this by inspection, just by looking at it. So imagine coming across here and just drawing vertical lines. So think about going through here and drawing a bunch of vertical lines. Now notice in this picture, nowhere that I draw a single vertical line can I hit this graph more than one time. So from this, we can see that this is a function. Now, why would this test work? Now, think back to when we learned how to draw lines. The equation for a vertical line is like x equals a number. So I'm just gonna make something up. Let's say x equals 7 for this one right here. So for every point on this line, we have an x value of 7. Every time it intersects the graph, that gives me a point on the graph. The point would be 7 comma something. Well, if it only hits the graph one time, that means if I inputted in 7, it only gave me one y value. So from one input, we only got one output, which means it is a function. So if we were to take a look at another picture, you'll see how easy this is. Let's say the picture looks something like this, and I ask you, does this picture represent a function? Well, again, all you try to do is try to imagine, can you draw a vertical line and hit this thing more than once? And hopefully it's obvious somewhere over here, act like that's a vertical line, you can actually hit this graph in 3 different places. 1, 2, and 3. That means for this specific x value, whatever it is, there has 3 y values to go along with it, which means you plugged in that one x and it gave you 3 y's. So this is not a function. Okay, so very, very easy to do. Again, no work at all. You don't actually have to draw the vertical lines. You're just looking at it and say, if I draw a vertical line everywhere, can I ever hit it more than once? Now, the last thing that we're going to have to take a look at here is, what if we're given an equation? What if we're just given an equation? How do we tell whether or not it's a function? So let's see, equation here. Well, we got a little bit of good news and bad news here. At this stage, we just have to memorize a rule. Now, unfortunately, this rule's not complete. The farther you go in math, you got to add some more things to this rule. But for us right now, here's what the rule states. It says, if a y is raised to an even power or inside an absolute value, it is not a function. Okay, so all we're going to look at here are the y's. Notice it doesn't say anything at all about x's. We don't care about the x's. We're just going to look at the y's. And if we ever see a y raised to an even power or in an absolute value, then automatically it's not a function. So let's do the same thing. Let's take a look at a few equations here. Let's see, 3x squared y cubed plus the absolute value of x plus 7 is equal to 5y. Let's do that. All right, so there's a really scary looking equation. But believe it or not, we can actually tell whether or not this would represent a function or not. So all you got to do is just move across the equation until you find a y. There's a y. Is it raised to an even power? Nope. Is it inside an absolute value? Nope. So that one's fine. Keep going until you see another y. There's a y. Is that raised to an even power? No, because remember, that's a 1 right there. So it's not raised to an even power. Is it inside an absolute value? Nope. So this is a function. So you got to know the rule, but as long as you know the rule, it's very, very simple. All you got to do is just inspect the equation and say, is a y raised to an even power or inside an absolute value? So let's see, x cubed minus y to the 5th times the absolute value of 3x plus 2 is equal to 7x squared minus 4y to the 6th. All right, again, let's take a look at this scary looking thing. Does this thing represent a function? Again, all we gotta do is start moving across till we find a y. There's a y. It's raised to an odd power, so that's good. It's not inside an absolute value, so that y is fine. No more y's. Oh, there's a y. Oh, it's raised to an even power, so you're done. This is not a function. All right, so that's it. That's really all you got to do to determine whether or not something is a function. So remember, domain is the values that we're allowed to plug in. Range is the values that come out. And the way that we determine whether or not something is a function by looking at how the information is given to us. As a set of points, we're looking for repeated y values with a given x value. For a graph, we're going to use the vertical line test. And for an equation, we got to follow our rule that if y is raised to an even power or inside an absolute value, then it's not a function. Next time we'll take a look at what function notation is.